Hi everybody, today I'm going to show you how to draw models of compounds. So we're going to start with Bohr models, and you draw them a little bit differently depending on if they are ionic or if they are covalent. So let's start with ionic. So in the last few videos, you saw how to draw ions based on the fact that you know that they want to have a full outside shell to be stable. So for example, if we were going to draw lithium, I'd look at my periodic table and see that a lithium atom has 3 electrons because that's its atomic number. 1, 2 in the first shell, and a third one in the second shell. Cool, there's my lithium. Now, what if I drew a chlorine atom? I'd look at my periodic table, see that it's number 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, how convenient. Lithium has 1 extra electron that it wants to lose in order to make it stable, and chlorine is looking for 1 more electron to make it stable. So what I'm going to do is actually take this electron. In an ionic compound, the metal donates or gives away an electron to a non-metal. Okay, so now, of course, I'm going to take away the outside shell. It's empty. We don't need it anymore. And just like from the last lesson, the way we draw an ion or indicate it's an ion is to put square brackets, put a plus sign. Chlorine is also an ion because it's gained this 1 electron. And we do a minus. There you go. You have drawn a Bohr model of an ionic compound. I'm going to show you on one that's a little bit more complicated. We're going to draw one with magnesium. I'm going to draw it over here. So we're still on ionic. I'm going to draw magnesium. I look at my periodic table and I see that it has 12 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Cool. Okay. So how many electrons does this need to lose or gain to become a stable ion? It needs to lose these 2 electrons in its outside shell. You got it. Okay. Now, if it was going to bond with fluorine, look at your periodic table, see that fluorine has 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, maybe you're already seeing the issue I've set up for you here. Magnesium wants to lose 2. Fluorine wants to gain how many? Just 1. So magnesium donates its electron, or 1 of its electrons, over here to fluorine. This fluorine is great. It is happy. It is its most stable self, and it is an ion, a -1 ion. Remember, scientists are too lazy to draw ones. Okay, but what about this magnesium? It is not stable yet. What it's going to do is find another fluorine. 1, 2, 3, 4, 5, 6, 7. Oops, I did not go in order. 1, 2, 3, 4, 5, 6, 7, 8, 9. Doesn't really matter where that empty spot is, because it's going to get full from taking this electron from magnesium. Okay, now I'll draw it in red so I stay consistent. This is the donated electron, or the stolen, if you want to think of it that way. Now, this fluorine is also -1. And this magnesium lost 2 electrons. When you lose 2 negatives, you become more positive. That says 2 plus, that looks more like a times. Hold on. There we go. Has 2 plus, you could write +2. They're interchangeable. It doesn't matter. So this is now my compound, magnesium fluoride. You would write the formula as MgF2 because you needed 2 fluorines to balance out the electrons from that magnesium. So that's an ionic compound, a Bohr model of an ionic compound.